It is the most recognizable symbol of digital failure. A user tries to load a web page, the connection fails, and they are left staring at an offline dinosaur standing in a pixelated desert. Modern web development focuses heavily on local performance. Developers can move heavy data parsing to a background web worker, maintain a pristine main thread, and achieve a flawless 60 frames per second animation rate. But those optimizations exist within the browser's memory. The moment the user takes their laptop onto a subway and loses their Wi-Fi connection, the entire application vanishes. This diagram shows the standard communication model of the web. Most applications operate through a direct, synchronous pipeline between the browser and a remote server. When a physical barrier severs that connection, the application has no local mechanism to resolve the request. Surviving an offline scenario requires a change in strategy. Instead of optimizing the internal logic of the web page, developers must build a system to manage the gap left by a dropped signal. To manage that gap, we introduce a distinct structural layer in the middle space between the user's browser and the distant server. This layer is the service worker, an independent script running outside the user interface. Acting as a programmable network proxy, every single network request your application makes must flow through it before reaching the network. By routing all traffic through this independent middleman, developers gain control over the front door of their application, regardless of whether the wider internet is available. Setting this up requires splitting the application code. Developers register the worker in the main application file, but place the actual proxy logic inside a dedicated, isolated file. Inside that file, they establish 3 specific event listeners: one to cache the core assets, one to clean up old caches, and one to intercept network traffic. Within the interception block, the event.respondWith method allows a developer to programmatically overwrite the browser's default network behavior. Instead of letting the browser fail when a server is unreachable, the script provides its own response. This chart shows a cache-first strategy. When the browser asks for index.html, the service worker intercepts the request, checks a local saved inventory, and returns the file immediately without ever attempting to contact the remote server. The application is now a self-contained system. It no longer waits for a server to provide its basic structure. It generates its own responses from local storage. Consider a user relying on this application who goes underground on a fast-moving subway train, causing their signal to drop. Instead of triggering a connection error, the application remains active. The HTML structure, the CSS grids, and the JavaScript framework all render from the cache as if the connection were still live. This interception architecture is the technological foundation for progressive web apps, or PWAs. Because a service worker can intercept all outgoing traffic, browsers require a secure HTTPS connection to prevent man-in-the-middle attacks. Without this encryption, a malicious script could theoretically redirect every request the user makes. Service workers also follow a unique lifecycle. A newly updated worker will not take control of the page until all existing tabs of the application are completely closed, ensuring the user doesn't experience a version conflict while the app is running. By implementing a network proxy, the application becomes independent of the server's immediate availability. It functions as a localized system that persists even when the network signal disappears.